let's say you know what the structure of the compound is and you know what atoms are joined together where, then all you need to do is look up their electronegativity values and do a little math, see what sort of tug of war we have going on. And if there's a big difference in their electronegativity values, then actually an electron is going to be transferred, like the situation of sodium chloride. So NaCl. Now, if you look at the previous slide, you can actually see the electronegativity value for sodium, and I looked it up, is 0.9. The electronegativity value for chlorine is 3.0. Now, have I talked about, I lose track, but I think I did. Anytime you see this delta, delta means change in, so, or difference. So actually the difference in electronegativity, and here it's the absolute value, is simply if we take 3.0 and from that subtract 0.9, we get a whopping 2.1, and that's pretty high for electronegativity difference. So like this slide, or like we talked about before, what's going to happen is the one with the higher electronegativity value is going to, it's like a tug of war. Okay, it's going to actually, electrons going to be transferred. That, like we said before, is going to be now -1. This is going to be a +1, and then we're going to have that dot, 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 dot. The ionic bond is going to be formed. So those 2.1 is pretty big, okay? Now, if the if the difference in their electronegativities of the atoms being stuck together is relatively small, so what's relatively small? Okay, the bond, chemical bond between them, electrons are going to be shared, not transferred. So actually we have kind of this difference. I'll put this whole thing up here. The 2.1 I showed for sodium chloride, okay, that was actually in excess of 1.7. So if the difference is 1.7 or greater, then an electron is transferred. Okay. So anything less than, anything less than that is actually going to be what we call covalent. So electrons are going to be shared in these cases. Electrons are going to be shared to create that bond. And I haven't talked much about that, but you'll just have to take my word for it for now. But the deal is that it's possible, see this 1.2, it's possible, for instance, to have a situation where, how do I say it, they're shared but not, the electron cloud is skewed. So let me do a couple of examples here. I picked methane, so CH4, it has a carbon here, and we have 4 hydrogens. So we could look at the nature of any of these chemical bonds, okay? So a chemical bond here. So let's just pick that one. So in order to understand kind of the nature of that chemical bond, we would need to look up the electronegativity of carbon. And if you look it up, you'll find that the electronegativity is 2.5. Then we'd also need to look up the electronegativity of the hydrogen, and that actually is 2.1. Oops, did I get that right? Yeah, 2.1. So the electronegativity difference is 0.4. All right, so definitely we are not at the 1.7 threshold. The tug of war is such that it's not going to go to the carbon, the one that's more electronegativity. They actually are going to be shared. Electrons are going to be shared to create that chemical bond. That's a covalent chemical bond. But you can see here that actually we call it a weakly polar. So let me show you kind of the convention that we do. So the carbon is more electronegative, and so that is actually what we call partially negative on the carbon, and each one of these hydrogens are what we call partially positive. The other example I chose is actually water. So here's a water molecule down here. We have a single central oxygen atom and 2 hydrogens. Okay, now again, we look up hydrogen on its electronegativity is still 2.1, like we said before. The electronegativity of that middle oxygen atom is 3.5. So if we go ahead and calculate the difference here, we've got now a difference of 1.4, which means that it is approaching that 1.7. Electrons are still shared, but they're definitely not shared equally. So again, we say that the one with the higher electronegativity, tug of war, it's what we call partially negative. It's got electrons are shared more over there than they are over the hydrogens. Okay, so we say actually in that case, that oxygen, although electrons aren't transferred, it's running around with kind of like a little negative charge there. So it's what we call strongly polar. So I have some figures here to kind of go along with what I just said. These are 3 compounds. This would be like, this would be something like O2, like an oxygen molecule. If you look up the electronegativity of each oxygen atom, it's the same. So the electronegativity difference is what, 0? Okay, and this could be something like our water molecule, where we end up with a partially negative and a partially positive end. And this actually could be something like our sodium chloride. Except as it's written here, this would be what our chloride ion, and this would be our sodium ion. Okay? And this actually just kind of reinforces that.